Okay, in this video we're going to use partial fractions for integration, and let's see this problem now. We've got the integral of 2x over x squared minus x minus 2 dx. Well, as you can see here, the first thing we can notice is that we've got in the denominator we've got a quadratic expression, so we can break this down, factorize it, so it ends up with 2x. If we take the quadratic of that, we end up with x minus 2 times x plus 1. If you're not familiar with the quadratic equation, you can go back and check my videos for quadratic equations. And now, well, the first thing I do actually is get rid of the constant. We're going to pull it outside the integral. I just rewrote this. And now we can do a partial fraction. Let's pretend we don't have the integral symbol and a dx. Well, it's just a normal fraction, so we can just take the partial fraction of that because we've got two pieces in the denominator. Well, that's exactly what I'm going to do. Well, I'm going to break this down, so I'm going to put a over the first piece in the denominator, which is x minus 2, and then b will take the second piece, which is x plus 1. And now I'm going to write down simplify that is by getting rid of the denominator. So if you got rid of the denominator, we're going to multiply with the denominator on this side, the left side. We'll end up with x only. And then here, we're just a would be times x plus 1, and b would be times x minus 2. So that's going to be a times x plus 1 plus b times x minus 2. Well, that's easy. Well, the first thing we do, as usual, is we choose appropriate values for x to find a and b. And here I'm going to start with x equals to minus 1 to equalize that with 0 so we can find b, right? End up with 1 unknown. So substitute that with all the x's we've got. So in this side is going to be minus 1 equals to, well, the whole thing now is going to be 0 because minus 1 plus 1 is 0. So a times 0 is 0, and I have to write it down. And here we've got b times minus 1 minus 2, which is minus 3. So minus 3b. So b equals to, well, minus 1 over minus 3 is just one third. Right, so that's b. Now, same thing I'm going to do for a. I'm going to find appropriate values for x to find a, and that's going to be positive 2, right? So we can equalize that with 0. So rewrite this: 2 equals to a times 2 plus 1, which is 3, so 3a. Which means a equals 2 over 3. 2 over 3. And that's our a. So now what we're going to do is just substitute the values of a and b we've got with this equation, the partial fractions, and then integrate. Instead of that, I'm going to put the partial fractions that we've got. So that's exactly what I'm going to do now. That's, by the way, that's a over x minus 2 plus 1/3 over x, which is b, x over 1. That's exactly what I did, and put the 2 out. Now I'm going to multiply the 2 inside the bracket, inside the integral. So we get 2 times 2/3 is 4/3 over x minus 2 dx plus 2 times third is 2/3 over x plus 1. And by the way, we're just going to integrate each piece individually. Now it just looks a lot easier to integrate. But the first thing I usually do is pull the constant out. It just looks a lot neater. So 4 over 3, and then the integral of 1 over x minus 2 dx plus, same thing here, pull the 2/3 out, and then the integral of 1 over x plus 1 dx. I'm running out of space. So I'm just gonna take the integral of that, and you know the integral of 1 over x minus 2 is literally the natural logarithmic of the denominator, and then plus, same thing here, 2/3 times the natural logarithmic of x plus 1. Oh, and don't forget plus c. And that's the should be the final answer. Let me just zoom out. So yeah, that's the final answer. We got 4/3 natural logarithmic of x minus 2 plus 2/3 natural logarithmic of x plus 1. So yeah, that's just an example of how to solve using the partial fraction. So what we usually do first is, if we can break it down to 2 brackets, that would be good. So we got quadratic, we broke it down first, and then we just use a partial fraction method. We forgot about the integral for a bit. Let's just solve the partial fractions. So we got values for a and b, and then we plotted that back. We substituted that with the values of a and b with these partial fractions, and then we solved the integral. We take the integral of each partial fraction on its own. It's just a lot easier, and we end up with the final answer. Usually in taking a partial fraction, we're going to end up with natural logarithmic, because, well, the integral of a fraction usually, and x if the variable is in the fraction, so usually we're going to end up with natural logarithmic as it is. So yeah, that was it. Good luck with the integration. Now in the next videos you'll see videos of me explaining the differential equations. It's a bit hectic, so see you in the next videos.